So today you're going to see that you can prove whether two triangles are similar just by looking at their angle measures. Two triangles are said to be similar if they have two angle measures that are equal. That pairs of really shouldn't be there. It doesn't make sense. So again, they are considered similar if they have two angle measures that are equal. And that makes sense because if you have two equal angle measures, then the third angle measure is also going to be the same. So something that's really important to know here is also that the angles of a triangle add up to 180. And we're going to use that fact a lot to help us figure out whether there are two congruent angle measures. So taking a look at number one, this one is really easy because you right away see that there's one angle that's 31, A and A prime, so those correspond and are congruent, and then B and B prime are both 103. Those correspond and are congruent. So that's enough to say, yes, these triangles are similar. Because they have congruent corresponding angles. And we can go a step further and find the third angle in each one if we'd like. So 103 plus 31 gives us 134. And then 180 minus 134 gives us 46. So in both cases, C would be 46 degrees. Now proving that all three angles are congruent. Therefore, the triangles are similar. They're not congruent triangles because obviously they're different sizes. But by having the same angle measures, they are similar triangles, which means that there is a ratio that would make one side equivalent to the other if you were to multiply, kind of like a scale factor. All right, so number two, same thing. We have 31 and 103 again. So A and A prime are both 31. But if you look at B and B prime, they're 85 and 103. So that is enough to say, no, the triangles are not similar. Because only one pair of corresponding angles are congruent. And again, just like I did in the last one, we could go a step further and prove that C would not be the same because of B being 103 and 85. So again, we know from the other side that 103 and 31 is going to make 134, and then 180 minus 134 is 46. So this angle, C prime, is going to be 46 degrees. But then if we take a look at the larger triangle, if we do 31 and 85, we get 116, and then 180 minus 116 is 64 degrees. So C in this case would be 64, not 46. So definitely proving that those two triangles are not similar because there's only one angle that's congruent. So the sides would not be in proportion to each other. All right, I'm going to do two more examples with these with you, and then one more harder problem on the back. So taking a look at 3 and 4, again, we have some different sized triangles and we want to prove whether they're similar or not. So taking a look at number 3, we see that obviously A and A prime are corresponding congruent angles because they're both 72. But then in the smaller triangle, we're given C, and in the bigger triangle, we're given B. So we don't see necessarily another pair of corresponding congruent angles. So we have to find them and then decide whether they're similar. So in the first one, if I do 78 plus 48, 7, 8, and 4 is 12, I get 120 degrees. And then 180 minus 120 is 60 degrees. So my B is 60 degrees, where if you look at the bigger triangle, B prime is also 60 degrees. So I'm just going to do the work on the larger triangle to make sure that C is the same as the smaller C in the smaller triangle. So 60 plus 72 is 132, and then 180 minus 132 is 48 degrees. So now I have enough to prove that those two triangles are similar, and we can write the triangles are similar because all three corresponding angles are congruent. Okay, so number 4 is similar to that as well. In number 4, again, we see A and A prime being the same measure. But then in 4, we're given, or in this larger triangle, we're given the 84 for B, but nothing for B prime. In the smaller triangle, we're given 32 for C prime, but nothing for C in the larger triangle. So we're going to find the missing angles in each case and then prove whether they're similar or not. So in the first one, we have 64 and 32, or in the smaller one, which gives us 96. And then 180 minus 96 is 84 degrees. So that proves here that B and B prime are going to be the same. And then we can bring the 32 if we want to prove that A and B are the same in this larger triangle. We have 64 and 84 is 148. And then 180 minus 148 gives us 32 degrees, proving that those, again, are similar triangles. Because all three corresponding angles are congruent. All right, so you're going to continue with 5 and 6 on your own after the video, but let's jump down to number 7. So now in this case, again, we have two triangles that we're comparing, but now we also have angle or side measures that we're going to have to deal with. So if we can prove that the triangles are similar, we can use that idea to write some ratios to find missing side lengths. So in this case, we see the 92 and the 92 for B and B prime, and 59 for A and A prime. So that's enough to say that the two triangles are similar. So here, part A is triangle ABC similar. So that little symbol there means similar to triangle A prime, B prime, C prime, and explain. So yes, the triangles are similar. Because all the corresponding angles are congruent. So hopefully you've got that phrase down now. We've written it 5 times. All the corresponding angles are congruent is what you need to know for proving that shapes are similar. All right, and now it says determine the length of A prime, C prime. So here we have AC is 6.1, and we don't know A prime, C prime. But what we do know is that AB is 3.2, and AB prime is 5.12. So we can use that to write a ratio or a proportion to solve for the side AC. So if you recall your proportion work from last year, we want to make a proportion that sets those two lengths equivalent to each other and has a value for x that we can solve for. So we can go from AB to AB prime. AB is 3.2 and AB prime is 5.12 or 5 and 12 hundredths. And then we have AC back to the smaller triangle. So we're doing small over big. Make sure you're being consistent whenever you're setting up a ratio or a proportion. And so then AB prime is, or AC rather, is 6.1 over AC prime, which we don't know. So we're going to put an X. So now solving a proportion, we cross multiply. So 3.2 times X gives us 3.2x. And then 5 and 12 hundredths times 6 and a tenth. Take out my calculator. So we have clear 6.1 times 5.12 gives us 31.232. Then we're going to divide by 3.2, divide by 3.2, and x equals 9.76. So we found that AC prime is 9.76 units. All right, and then part C, very similar situation, determine the length of BC. So we know that BC prime is 8.96, but we do not know BC, but we can still use the same idea of a proportion to figure out that length. So I'm going to do the work over here so I don't have to scroll down. Using the same idea of small over big, I have, starting with my ABs, because that's what was originally given, AB is 3.2 over AB prime is 5.12 equals, now CB we don't know, so that's going to be our X, over CB prime is 8.96. Same thing as before, we're going to cross multiply. So 5 and 12 hundredths times X equals 3.2 times 8.96, which is 28.672. Dividing by 512, we get 5.6 for X. So now we've found that dimension as well. So X is 5.6 units. And we've done everything that we need to do. So tonight you're going to see a problem very similar to that. Take your time, work through it slowly, set up your proportion with corresponding sides, just like I just did. So if you need to, set up a ratio like this so you always remember what triangle you want in the numerator and what triangle you want in the denominator. All right, so you have to make sure you go back to numbers 5 and 6. We'll be around to help you out.